Hello, kids. Oh my gosh, there's a bunch of stuff going. I'm so excited. You'll see that it says on my shirt, I'm a happy camper, because we are at Mr. Patrick. Oh, stop for a second. I made my own sign. We're getting a little bit more high tech. I'm not sure what Miss Christie thinks, but we're going to be at Mr. Patrick's laboratory. It's going to be
still my kitchen.
I know, honey. I know. All right, we get to be inside. This last week, we had a great time. We're not doing experiments. I'm going to take my goggles off real quick. This last week, we went into the largest laboratory outdoors, and we did all kinds of cool stuff. Kids, keep posting stuff down below of the different things that you did. We had a big time, okay? We had a big time in 3 episodes outdoors. Now we're back indoors, and we're going to do some really cool stuff. This is really cool. We're going to have a great time with all the things we're doing, all right? Now, that sound. All right, what we're going to be doing today, you're definitely going to need your goggles, okay? Not only do I have my cool shirt today, I have my lab apron that I'm going to wear because I want to protect my clothes from some of it, but I definitely need to wear my goggles. That's going to be super important today, okay? And when we go to do experiments, I'm going to put them over my eyes. But what I want to talk about today is what we're going to do this week. We're going to have 3 episodes on heat and temperature. Now, heat and temperature are different from each other. Okay? So I'm going to teach you the difference. Now, you probably had your mom say, I don't feel good, Mom. Get the thermometer, and she takes your temperature, and she wants to know what the temperature of your body is. Okay? All of us have done that before, gone to the doctor and had that done, and we've had that done. But heat's a little bit different. Heat is a movement of energy from one place to another. Now, something can be cold or hot, okay, but we have energy. Now, I got to really help us, kids, okay? All right? And this is a little hard to understand, so you got to really listen. Okay, we know that the sun makes heat. That's a good example, okay? But there is really in the world, there's heat and there's lack of heat. Heat and lack of heat. Those are very different from one another, okay? And see, here's what's happening, okay? So I want you to do an experiment. I'm going to have to pretend because I don't have somebody here with me. But here's what you're going to do. In just a minute, you're going to high five your mom or your dad, but you're not going to really high five and be done. What you're going to do is you're going to touch your hand to them. Not yet, but you're going to touch your hand to them. And what I want you to decide between the two of you very quickly is when you put your hands together, whose hand is warmer and whose hand's colder. Okay, so one more time. You're not going to high five like that. You're going to put your hands together, and you're going to decide as soon as you put your hands together, whose hand is hot and whose hand is cold. So I'm going to give you a second. Ready? All right, do that. All right? All right, now whose hand was warmer and whose hand was colder? Perfect. Okay, you got it? You know? All right, great. So let's talk about heat. Heat is energy that moves from one place to another. So let's say that I high-fived my son Braden, and his hand feels warm to mine. That means there's energy moving from his hand to my hand, and I call that feeling warm. But he doesn't feel warm. He feels cold. Okay? He feels cold. Why? Because heat's going from him to me. Now, what do you think happens if you were to touch hands like that, and you were to wait like 20 seconds? Do you think you'd be able to know whose hand is warmer than the other? Probably not. Why? Because our hands would be the same temperature. Okay? Our hands would be the same temperature. That's why I wanted you to know as soon as you touch. Now, heat is a movement from energy from one place to another. Okay? So, movement from one place to another. All right, we got that. Now, catch this. There is heat and there's lack of heat. There's really no such thing as cold. Now, let me use a different example that makes it a lot easier, okay? There's light and there's lack of light. All right, kids, what do we call lack of light or no light? Yeah, it's dark. It's dark. We gave it a name. But see, the sun makes light, but the moon doesn't make dark, does it? No, it doesn't. Okay, so let's think about that. There's light and there's lack of light. We call it dark, but there's really not dark. Okay? So when I go to bed, I turn the light on, I get ready, I get in bed. When I turn out the light, there's just no light, and so it is dark. So the same thing, so we understand that when there's light and lack of light. That might be fun, Mom, to go up to your mom or dad and say, hey, Mom, it's really lack of light in here. See if they understand what that means. Okay, because you're smart. Okay, so heat works the same way. We have heat and we have lack of heat. Okay, so heat and heat going away. Now, why does something feel cold to us? It's because when we touch it, it's pulling heat away from us, and so we call that cold. Let me give you an example. Here's what I'm going to do. I'm going to get an ice cube out of my freezer. I'll get a couple of them. Okay, so when I take an ice cube, and everybody's done this before, when I put it in my hand, it feels cold. Well, it feels really lack of heat from what we just learned. But why does it feel cold? Because there's energy moving. Okay, so here's our first question. Where's the energy moving from and where's it going to when I have it in my hand? Where's it going from and where's it going to? It's going from my hand to the ice, okay? Now, to the ice, if the ice had feelings, it would say, woo, your hand is warm. It didn't say anything. Okay, but I can tell you it feels cold. Have you ever been outside and maybe it snowed outside? And you go outside and you make snowballs and you're throwing them at the fence or maybe throwing them at your brother. Don't throw them at your brother. Throw them at the dog. Don't throw them at the dog. Throw them at your dad, yeah, or throw them at somebody, and you throw them, but your hands get real cold, and they're all got grass all over your hands, and you put your hands to wash your hands, and even if you turn the cold water on, it burns. Why does it burn? I didn't turn on the hot water, turn on the cold water. My hands are so cold that when I stick them in the water, where's heat coming from? The water out of the sink, and that heat's going into my hand, and my hand says, it's burning me. Why? Because there's a movement of energy. What do you think happens if I touch something that's exactly the same temperature as my hand? Does it feel hot? Does it feel cold? No, it doesn't feel either because it's the same temperature. All right, is that making sense? So I want to show you what's going on. You'll see my experiment stopped here because I'm going to show you what was happening, okay? So we're going to take ice and we're going to take dry ice. And Miss Christy's going to get a little closer with the camera so you can see. Now I have my lab apron out so you can really see. But I'm going to take that ice that was just in my freezer. And then Miss Christy, make sure you catch what I'm doing right here. I'm going to get some dry ice. Okay? Now notice what I'm doing. Okay? Now you may think, where do I get dry ice? Mom and Dad, you need to make sure, okay, I got dry ice. You can get them in a couple different places. If you live in a city area, you can just Google dry ice near me and you can get dry ice. Okay? If you live more rural areas, if you'll ask one of your local grocers, when they bring in seafood and things like that, it's packed in dry ice so that it can stay really, really cold, okay, so it can stay fresh, okay, and some of their frozen things so you can ask them to get it. So I found a company in the area that has dry ice. So I have it in a small ice chest on the other side here, but here's what you need to know. You need to wear gloves. It's so cold. What do you mean so cold? Well, let's look at the cards here real quick. Ice in my freezer is 0 degrees Fahrenheit. And I know that because that's what the temperature says when I push the buttons on my freezer. Now, what I'm going to do is I'm going to first put on my goggles. Now, my goggles are all fogged up, so I stop out of the way, get out of the way, get them all unfogged, and I'm going to get a piece of dry ice. Now, dry ice. Here's one piece of dry ice. So I want you to look and see what's happening as she zooms in, okay? You're going to see that it looks like smoke coming off of it. Now, first thing, kids, okay, as you look at the ice, does anybody know the formula? Does anybody know the formula for ice? It's water, right? It's H2O. Okay, we got that. That's great. Okay, it's frozen water. Now, back to where I can do my experiment. Dry ice is really different. Now, it says ice, but it's really not ice. Okay, it's carbon dioxide. Now, in a video before this, we talked about carbon dioxide is the gas that you and I breathe out all the time. Okay, and so what I want you to see is that, and Miss Christy's gonna get real close. I want you to see the temperatures again. This one is 0 degrees Fahrenheit, and this one's negative 110 degrees Fahrenheit. This one is 0 degrees Fahrenheit. That's regular ice, and negative 110 degrees Fahrenheit. This is 110 degrees colder. Now, something weird is happening. Miss Christy, as you get close, you're going to see that the ice looks slick on the outside. What happens when I put ice out? Okay, it melts. Yeah, it starts to melt, and here's why. All the heat from the room is going inside there, and as it starts to go, the heat of the room starts to go in there, it starts to melt, and everybody knows that. We know that when you put ice into a drink, it gets colder. Okay, because when you put it in your drink, the temperature of your drink, all that warmth goes into that ice, and what does the ice do? It starts to melt, but it makes all of your drink cooler. Okay, dry ice does something very different. Now I'm gonna pull out one more piece while she's showing that one. I want you to see what's happening. Let me grab one more piece. There's a good one. Look what that thing's doing. It's not actually melting. It's going from this really, really low temperature to room temperature. It is getting so much heat from the room so fast that it doesn't become a liquid. Sometimes, and notice what it's called, dry ice. It never gets wet. Sometimes if you talk to your grandparents, they would call it hot ice, okay? Why would they call it hot ice? If I touch it with my fingers, it burns. It is so cold, it's burning my skin. And so I don't want to have that on my skin at all. Now, what I want you to see happen is what happens when I drop this into water. Now, look at that. That's called a fog bank. And what's actually happening, I'll drop that second piece in there real quick. What is happening is down here at the bottom, heat from the water, it's warm water I put in there, is going into that and it's changing it very quickly to gas. And when it's becoming gas, is it's going up through here, it's changing temperature. Some of the water, boy, it almost looks like stuff you do at Halloween, right? Some of that water is coming out as vapor. So that carbon dioxide is so cold, it's making the water, now keep it right there, Miss Christie. See that? You can see it actually moving. Now, it's really cool if you've ever seen some science movies, okay? Sometimes they'll put things in different containers like all of these, and it doesn't matter what size container you have, okay? They can all do different things, and then it looks like, I'm a mad scientist. But it's just fun, okay? It's fun. Notice I still have that glove on to protect my hand. I do not want it to burn my skin. So what we're really talking about here for a minute is the movement of heat, okay? The room is warm. That dry ice is so cold that when I drop it in water, I get this really cool effect. Look at it going over the edges, okay? Over the edges of the island. Oh, this one's really, really cool looking. Watch as I blow it. Yeah, man, this one's fun. This is great. We're gonna use dry ice in this video and our next video, okay? Because there's energy moving from one place to another. Now, kids, I gotta give you a couple of words, okay? I've got to give you some very important words that we're going to be using. We're going to be talking about two kinds of reactions. Those two kinds of reactions are what are called exothermic reactions and endothermic reactions. So let's take those words apart here for a second. We're going to talk about exothermic reactions. It's hot. That's exactly right. It's really, really hot. So let me explain. Everybody knows what an exit is. You go out when you exit. Endo, in sounds like you're coming in. So we're talking about where heat is going. Heat is exiting, heat is going in. Now you got to really catch it. Ready? Here it comes. If heat is exiting, it feels hot, hot, hot. So we're going to have reactions today. And you heard that sound just a minute ago. We're going to have hot reactions that are taking place. In an endothermic, it's going to be pulling heat in. And so when I touch it to my hand, it would feel cold. So that ice cube is going to feel cold because it's taking in energy. So we're going to talk about energy moving from one place to another. And these are really, really good examples. Okay? But what we're really going to focus on today is we're going to focus on the exothermic reaction. So let's go back to what we just said. Exothermic reaction, energy is exiting. And so things are going to get hot. Okay? So that's why I wore my crazy shirt. We're going to have some crazy fun here for a little bit. So I'm just going to move a couple of things real quick. Now, we can start very simple with something like a candle. Now, I'm going to go ahead and take my lab apron and put my lab apron on before I get into the experiments so that I make sure that I am taking care of my clothes as I go along. Now, a candle's really not going to hurt you, and most people have seen this before, but this is a very simple example of an exothermic reaction. Exothermic. So what's going to happen is I start the reaction. Oh yeah, got to have my goggles. Woo! I'm fogging them up today. Hang on. Put them right back on. Okay, here goes the experiment. All right, here we go. Start the reaction. And everybody knows what a candle looks like. Now, something's burning. Yeah, I can see it. As a matter of fact, if I put my hand close to it, I can feel heat coming off. So what we just said, is that an endothermic or exothermic reaction? It's exo. Heat is exiting and it's going to my hand, so I feel it. Now, this is a very simple one. What's burning here is wax. Now, if you had a fireplace at your house and it's wintertime and you burn wood, well, then you're going to have a whole lot more heat given off, okay? But it's heat coming off the wood as you burn it. There's a chemical reaction and it's giving off heat and you feel it as, whoo, that's warm when you're cold. That's why in the summertime, you don't have a fire. It's already hot. I don't need it to have a fire in the summer. So a candle is a very, very simple reaction. Now I'm going to do another reaction, and I'm going to explain, parents, what this is. This is steel wool. Some of you probably have this at home. And then we're going to take vinegar, okay? Now, what's really interesting about steel wool is not really steel. It's iron that has a coating on it, okay? So this one's really pretty cool. What I'm going to do is just take a pair of scissors, and I'm going to take some of that steel wool, and this happens to be like a steel wool that you would clean things and you would scrape things, okay? They've used it on furniture and things like that. And I'm just going to cut a section off. Actually, I want a little bit more than that. Okay, and so what I'm going to do is I'm going to take that piece of steel wool and I'm just going to use a bottle. You can use anything you want to, but this bottle is so disposable it makes it real easy to do. Now, what I'm going to do is I'm going to take a funnel so I don't spill any, and I'm going to put some vinegar on it. Perfect. Close that up so it doesn't get on me. Put that off to the side. Okay, so here's what's going to happen. Okay. What's going to happen over the next couple of minutes, I want to make sure that that steel wool gets really good and wet. And what's going to happen is there's a chemical reaction that's going on, and acetic acid is what's in vinegar. Okay, it's a weak acid, and it's going to eat away at the very surface of that steel wool. Now remember, steel wool is not steel, it's actually iron. And so I'm going to give it about 2 or 3 minutes to sit there. Now, because I can't wait that long for our video, I'm going to show you what turns out. I did this right before the video. Okay, and here's what ends up happening. It's actually, when I pull it out, it's going to allow the steel wool to start to rust. And within about 5 minutes, you can see it start rusting. Now, what's going to end up happening is, and you can see the rust. You can even see it on that paper plate as that rust has come off of there. Okay, and so it started rusting. Now, a car rusts over years, but this happened in about 5 minutes. So let me show you how that worked, okay? So I've given it about a minute and a half. It may need to go a little bit longer, but here's what I'm going to do. I'm going to pour out the liquid, okay, pour out the vinegar, and then what I'm going to do is just reach in there and pull out that piece of steel wool, okay? Squeeze it out, get the liquid off of it, and then here's all I did. All I did was I took that steel wool and I just spread it out. What I want to do is give it lots of air. Iron reacts with air to make rust. And so I'm just spreading it out really, really good. And then I put it on a place where it can sit there. In about 5 to 10 minutes, you'll see that it's already rusted. It rusts that fast, that chemical reaction. And it actually gives off heat. Now, it's not one of those heats you're like, whoa, I'm cold. Oh, that feels great. But it gives off heat pretty quickly. That's a really, really fast reaction. Okay? That's a really, really fast reaction. Now, let me get that vinegar off my hands real quick. Now, I'm going to take that same steel wool and I'm going to do something really different. Now, Miss Christy, when I do this one, you're going to have to be really close. Okay? So I'm going to take that and put it off to the side. And I'm going to take a piece of steel wool that I cut. Okay? And I'm going to cut that, and you'll notice that I spread it out really good. Here is a faster reaction. Now, what I'm going to do is I'm going to take a 9-volt battery. Now, a 9-volt battery is the battery that has the 2 terminals on the top. And this is going to be like what you would put inside of your smoke detector. Okay? Now, don't go get one out of your smoke detector. You can probably find one in a junk drawer somewhere, and you can test it out and see if it works. Okay? Positive and negative terminal, and here's what's going to happen. I'm going to cause this steel wool to react even faster than the first one. Here's what I'm going to do. Watch this, Miss Christy. When I touch it to this steel wool, you will see a reaction that starts to happen. And what is happening is I'm using electricity to start the reaction, and it's reacting with air very, very quickly. Now, you will notice that I have it where it cannot get on somebody, okay? And you'll see that reaction goes and goes and goes. Now, I'm going to tell you, because I've done it multiple times. Okay, I'm going to try again. Is there another place that didn't react? Okay, there's a little spark. Can try it in some different places. And then what has happened is I have caused that to react very, very quickly. Now, in that reaction, this 9-volt battery, when it touches the metal, causes a reaction, and it starts reacting with air very quickly. Now, the sparks that you can see are the energy that's being given off. That's exothermic, that's right. Energy that's given off, and it causes it to react very quickly. Now, rust, for those of you that are a little bit older, has the formula Fe2O3. Now, Fe on the periodic table is iron, reacting with oxygen. Normal rust is Fe2O3, okay? And it took about 5-10 minutes, and you can actually see that rust. This one is different. It's still iron and oxygen, but its formula is FeO. And so it has a different formula, and since it's a different formula, it's going to look different. As a matter of fact, if you feel a normal piece of steel wool, and then you feel this, you can say, oh, wow, that's almost powdery. It's made a new substance. And that's how you can tell a chemical reaction has happened. And you can see all that stuff that's fallen to the bottom, okay? So the best thing to do when you do this 9-volt battery is make sure you spread it out really good, and then start the reaction and just step back. If it stops somewhere, like I can see a place that didn't react right there, if I can get the battery in there, I can move it around and I can try it again, and I can get that reaction to go just a little bit longer. Trying to use it all up if I can, but I have to touch both terminals to it. So that's a really cool reaction. Both of them are exothermic. Okay, they're both gonna give off energy. Okay, really, really cool. Now, as if that's not cool enough, now remember, steel wool is really iron. Now here's one that you've probably used before. You ever used one of these before? It's a hand warmer. Okay, I like to go snow skiing with my kids, and sometimes it's super cold. I mean really cold, where your feet get cold and your hands get cold, and you buy a hand warmer to put in your pocket, okay? And so if your feet, they have some that you can shove in your boots, you can put some in your pockets. How's that thing work, okay? Well, you cut it open, and I started one of them so you can see it. There's a hand warmer, and all I did was you shake it up, okay? Now, you don't open the container, you don't open this plastic container until you're ready to use it. And then you shake it up really good, and you put it in your pocket. Now, it said on the instructions in about 15 to 30 minutes, it really starts to get warm. Now, it's really warm. I've had this one out purposely for about 30 minutes. Have you ever wondered what's inside? Okay, now, Miss Christy, you're actually going to have to get close on this one again. Here's what's going to happen here, okay? I'm going to take this hand warmer, and I'm going to cut it up. Now, this is not what you would ever do if you're going to put it in your pocket. I just want you to see what's going on inside, okay? Now, I'm going to cut the end of that off. I'm going to pour it on the table. Now, if you look at that the way it is right now, it looks like a black powder, and it's just piled up. Now, I'm going to spread it out a little bit. It's warm. Ooh, yeah, it's not hot, 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 but it's warm. Okay, and spread it out. Now, here's what's really interesting. As I grab it like that, it almost looks like a powder. It is. It almost feels like flour. Okay, if you were cooking flour, but what it is, it's actually ground up metal. It's ground up iron, and it's not little pieces of iron like this other thing that we just had. It's not like that. It's ground up. It's like if you used a grinder and you would get it into small, small pieces, and what happens is when you shake up this hand warmer and you give it oxygen, what happens? It starts to rust. Now, if I spread this out like this, and I leave it for a while, so I've already started that reaction, and I just leave it for a while, it is going to turn rust color all over it as it continues to rust. Every one of these are exothermic. How do I know it's exothermic? When I touch the container, is it cold? No, it's hot. It's warm. Okay? So heat's going from it to my hand, or in my pocket, or the boot warmer that's in my boot. It is giving off heat. That is exothermic, is giving off heat. Okay, so all three of these were iron. Steel wool, I put it in acetic acid, which is vinegar, ate off the surface, and then it rusts. I took another piece, touched it with a battery, and it caused it to react, and it rusted. It gave off heat. How could you tell? You could see the sparks. It was giving off heat. And then in this one, in a hand warmer that most of us have used, okay, it's been going about 30 minutes. It was nice and warm. Cut the end off. You would never do this, even in an old one. You don't want that to get in your face. You don't want it up your nostrils. You don't want it in your lungs. I'm just showing you how it works. When it goes bad, you throw it away. But I wanted you to see what it does. It's literally ground up iron that reacts so fast, it's actually rusting. And so it'll last for hours. It'll be warm in your pocket for hours. Now, if you read the instructions, we had one time and it didn't work very good, and I pulled it out and looked at the instructions again, and it says if it slows down, pull it out and shake it really good, give it some more air, put it back in your pocket, and it starts up again. It lasts for hours. Now the last one is probably the coolest one that I'm going to do, okay? In this last one, I'm going to take a bottle. I'm going to have just some blue soap so you can see what's going on, and then I'm going to take a little food coloring. There's a whole lot of pieces to this one, and this is hydrogen peroxide. Now, hydrogen peroxide is H2O2. Now check out that formula, H2O2. Now, remember, always say, cough into your elbow. Why? Science! And so we're going to have some hydrogen peroxide, okay? Now, there's going to be a reaction that happens. If you buy hydrogen peroxide, H2O2, when it sits there for a while, and it sits for a long time, it breaks down. Okay, when it breaks down, it breaks into H2O, water, and oxygen. The gas that you and I breathe all the time. If you were to accidentally leave the lid off for a while, it's going to go bad. It's not going to work anymore. How do you know if hydrogen peroxide works? Well, I cut myself or I scrape myself and I need to clean the wound, so I get a little bit of a cotton swab and put it on there. It starts to bubble, right? Well, here's what happens. In our body, we have what is called catalase, okay? Or peroxidase. Here's a little biology lesson. Peroxidase. On the end is the letters A-S-E. That means eater of. It eats peroxide. Okay? And so when I rub it on the wound, it's killing bacteria, but that peroxidase that's in my blood breaks it down, because you don't want peroxide in your body. So if it's made, it's immediately broken down. So what I want to do is I want to break it down pretty fast. So what we're going to make is what they call a warm volcano. Now, if I'm going to make a warm volcano, I need to make sure I have my goggles. And so here's where, and I'm doing it in a bottle. You can do it in different things. You'll see why I do it in a bottle here in just a second. Okay? So I'm going to take this hydrogen peroxide. This is just 3% hydrogen peroxide, Mom and Dad, that you would buy at the store. It's the same stuff. Okay? And I'm probably using more than I need just so everybody can see it happen. This will be more than you need. Okay? And so what I'm going to do is I'm going to take a drop of soap. Why? Make something happen. Okay? And then I'm going to take, since they call it a warm or a hot volcano, it's really not going to be super hot, but a warm volcano, why don't we give it just a little bit of red color? So I'm going to give it one drop. All right? Nothing happened. Right. Because all I have in there right now is hydrogen peroxide and soap and then a color. But I'm going to make something happen. Here's what I'm going to do. I'm going to take yeast. Yeast has a catalase in it. Do you remember from a while ago? A-S-E on the end means what? Eater of. Okay? So it's going to eat away peroxide. And so what I'm going to do is I'm going to take this, tear it open, and I'm going to take a funnel so I can get it all inside. Check this out. This is the big finale. Watch this. I'm going to take that yeast. I'm going to put it inside there. Okay? And then I'm going to shake it around a little bit. Give it all a chance to mix up. And then watch what starts to happen. Look what's coming up the bottle. It is starting to bubble. That's why I had the soap. I have the red in there, so it's a pinkish color so you can really see what's happening. Okay? This is where you can have fun with your kids. What's happening is it's taking H2O2 and it's breaking it. It's making oxygen gas. And as it's making oxygen gas, it's pushing it up the bottle. And so what's going to happen is, as I do that, you can hold the outside of the bottle and you can see it starting to get warm. But even better than that, what's going to happen is it continues to grow and grow and grow. I give it a little bit of chance to mix up really good. It's going to make more and more and more oxygen. And what's going to happen is, as it goes along, it's going to push those bubbles out of the top. And it takes just a minute till it gets to the top, okay? And what's going to happen is I'm going to have a foam that comes out the top. And that foam that comes out the top, as it gets close, you can do it one of two ways, parents. And I'm giving it just a little bit more. I'm going to give it another shot of peroxide just so that it can go. Okay, there it goes. Okay, here it comes. And so one of the things that you can do is the kids can stick their fingers in it and you can feel the foam. And what you're going to find is, with this foam, the foam is warm. Why do you think it's warm? Well, it's giving heat. So is it endothermic or exothermic? Well, all of today is exothermic. Check it out! It's just coming out! And so as it comes out, I can put it in my hand and I can feel that it's warm. Okay? If you don't want to have red food coloring on you and it's spread out so much it's not going to matter. But then if you don't want that red food coloring, then don't use food coloring. But the foam is warm. And so you get this warm volcano that's just making... Now, what is it? It's soap with oxygen bubbles in it. Okay? It's soap with oxygen bubbles in it. You might get a little yeast on you as well. Okay? As they come up through. And it just doesn't stop. Look, I think I stopped. Okay, I'll stop it. No, it's not stopping. Why? It's continuing to break down every molecule of it, and it's just covered in it, and it's warm. It's a warm volcano. The outside of the bottle is warm too. All right? What a cool, cool experiment. I'm going to wash my hands off real quick. So, kids, what did we learn today? As she gets video of that, what did we learn today? Well, there's two things that we need to know about heat. First, there's heat, and there's lack of heat. We call it cold. But is there really cold? No, it's just lacking heat. It's less heat. Okay? And so we learned today about exothermic reactions where heat is going out. So to my hands, it feels what? Hot. Okay, exothermic reaction, energy going out. And it's everything from candles to all these different types of things, and even our warm volcano. We took steel, we took actually steel wool, which is really iron, and we reacted it in 3 kinds of ways, and every single one of them were giving off heat. Okay, these are cool reactions. These are some of the most fun things you can do. What a cool thing, because it's just a little messy, so you can do it in the sink, or you can do it in the tub and then wash it down the sink. What am I going to do at the end of this to clean it up? I'm just going to pour it in the sink, wash it out really, really good, and mark that bottle, so if we do anything else, and by the way, in the next video when we get to that, we're going to use a bottle again, so great one to use again. Just wash it out really good. You know what? I'm having a great time. I hope you are too on Mr. Patrick's Laboratory. See you next time. Have a great time. Exothermic reactions. Woo! It's hot!